All right, question number 34. Elastic collision is a collision in which there is absolutely no loss of kinetic energy. Let's see. True. Elastic collision is the one that not only momentum is conserved, but kinetic energy is also conserved. Inelastic collision is the one cause deformation. So part of the kinetic energy will become potential energy. Okay. Number 35. A wide pool ball of mass 1 kilogram move at 10 meters per second. So 1 is M1, 10 meters per second, V1. Collide weighs 1.2 kilogram, M2. Red pool ball initial as rest, V2. After collision, the wide pool ball continue in the same direction. So if that is 10 meters per second, same direction is same going to the right. With a velocity of 3 meters per second. Neglecting friction, the velocity of the red ball after collision is, okay, so remember, the velocity has direction, okay? So the velocity will be either positive or negative. If you get a negative number, don't be surprised, but we don't know yet. Let's work it out. Okay, so momentum conserve. So 1 kilogram M1 times V1 plus M2 times V2 is equivalent to M1 times V3, the new momentum of the red ball, plus M2 times V4, which is the new momentum of the red ball, which is what we're looking for, right? You plug in number 1 times velocity is 10 plus V2 is 0, so 0 equal to 1 kilogram M1 times the new momentum, which is 3 because it's the same direction, so it will be positive as well. Plus M2 is 1.2 times V4. Okay, so 10 equal 1 times 3 is 3 plus 1.2 times V4. 1.2 V4 equal to 7. And then 7 divided by 1.2 is 5.8 nearest 10th. So it's 5.8. Let's see if it's 5.8. Okay. 5.8. Correct. All right, next, 36. A loaded wagon of mass 1,000 kilogram, the mass, moving with a speed 15 meters per second, strikes a stationary wagon of the same mass, making a perfect inelastic collision. Okay, inelastic collision. So there will be kinetic energy lost, right? What will be, and also it says perfect inelastic. So inelastic collision is kinetic energy convert to potential energy. And then the perfect inelastic collision is all the kinetic energy and convert to only potential energy. So perfect inelastic means the thing's not moving anymore. All right? What will be the speed? 0. So perfect elastic collision means they're going to stick together. That's what it means. Okay? So that means they're going to stick together and move at the same speed. So that will be m1 plus m2. Okay. So what you're going to have is m1 v1 plus m2 v2 equal, you add them up, times v3, right? It's the same thing over and over. We got that the first one, m1 is 10,000. 1, 2, 3 times 15. m2 is the same mass, but it's stationary, so it'll be a 0 equal. The second mass is the same as the first, so m1 plus m2 will be 20,000 times v3. All right? And then you divide, and v3 should be 7.5. Okay? Next. Inelastically result in a loss of kinetic energy? True. Two blocks of masses 3 kilogram and 5 kilogram approach each other with initial velocity of 4 and -6. That means they're facing each other when they move. The two blocks collide in a totally inelastic collision. What is their common final velocity? It's the same thing over and over. m1 times m1 v1 m1 v1 plus m2 v2 equal total collision, total inelastic collision, they stick together, m1 plus m2 times v3. And then v3 is what you're looking for. And all those numbers, you plug them in. 3 kilogram is m1, 5 kilogram m2, 4 meter per second v1, -6 v2, and you can find your answer. And your answer is 3 times 4, 5 times 6 divided by 8. -2.25. Okay, your answer is -2.25. Next. In Sacramento, 4,000 kilogram SUV is traveling 30 meter per second styles and crushed into empty school bus. Thank God it's empty. 7,000 kilogram traveling east on San Juan. So here, this is your V1. This is your M1. And then the school bus is your M2 and traveling east. The collision is perfectly inelastic. Find the velocity of the wreck just after collision. So it's the same thing that you plug in number, okay? M1 V1 plus M2 V2. And you add the mass up. So 4,000 times 30 divided by, you got 10.9. Okay. Okay, next, true or false. The law of conservation momentum states that the total momentum of object have before collision must be the same after collision. True. Momentum's always the same. All right, let's take a look at this question. Two blocks collide in a frictionless surface as shown above. Afterwards, they have a combined mass of 10 kg and a speed of 2.5. So, remember, it's afterwards. Okay? Before the collision, one of the block was at rest. This block has a mass of 8 kg. What was the initial speed of the second block? All right, so it's the same thing. Remember to collide and travel together. So M1 V1 plus M2 V2 equal collide together M1 plus M2 times V3. Oh, the pen's not working again. Oh, V3. Okay, now you have to plug in a number. It says that this block has, this block have a mass of 8 kg. And then it was initially at rest. So let's assume this block is M1. Initial at rest is V1. And then the two combined is 10 kg. That means your M2 should be 2 kg because 10 total minus M1 is 2 kg. And the speed of the second block, V2, we don't know. Right? Now you plug it in. 8 times 0 plus 2 times V2 we're looking for equal together is 10 kg times 2.5. Right? Now you just have to calculate. And you got 12.5. All right, 42. A 8.5 kilogram ball is moving with a speed of 8 meters per second towards a 4 kilogram ball at rest. The two balls collide and stick together. The velocity after collision will be 5.44. It's the same thing over and over. I'm just going to tell you yes or no after I calculate it. After calculation, answer is true. The cars are moving on level like the graph shown above. After collision, all three cars stick together. Find the direction of the combined car after collision. Alrighty, so the middle car is not moving. And then going to the left, the momentum is 4 times 2, 8. Going to the right, the momentum is 6. So with the middle one, obviously to the right or to the left is have more momentum, so it should go to the left.